I'm Tanya. My background is I've done nanotech with Chris Peterson. I ran Alcor for a while doing the cryonics thing, and now I'm trying to help cure aging.
Yay.
I work at the Sense Foundation with Aubrey DeGray. You know the guy, tall, skinny, beard. He'd fit right in if he could make it. I joined his group like 5 months ago, so I'm going to try to condense a 5-month summation into 5 minutes.
Good luck.
Month 1, I was driving a lot between Phoenix, Arizona. Boring. I'm sorry, Phoenix and Sunnyvale. Very boring. We're moving on. Month 2, getting used to the fact that I had 3 bosses. Cool. All interested, all intelligent, all really supportive. Month 3, realizing I'm over my head in the science. I don't understand anti-aging research, but I'm learning. Now month 4 was when it started getting really interesting. We have a research lab in Sunnyvale. It had 1 person when I showed up. Oh great, I'm supposed to manage 1 person who's been perfectly effective all by himself. That was fun. We hired 2 more interns. So now suddenly we have a little microcosm. Science is starting to go. We don't have the tools, but we have money. Now we have the tools. And as of just a couple of days ago, month 5, we have a new facility where the real science is going to start. Aubrey's approach, if you're not familiar with it, is to cure aging via an engineering strategy. Understanding why things happen the way they do in the body is so complicated and so confusing and so completely unknown in a lot of important ways. But we can see what happens. We can see the damage that these processes we don't understand, they cause. So the approach is to come up with some way to fix those things without worrying about all that or the stuff that's really hard to prove. And this lab and other extramural labs have been responsible for coming up with 2 particular compounds that attack 1 of 7 problems. So it's early stage stuff. But Aubrey has identified 7 different types of damage, all of which will require 7 different approaches, 7 expertises. Very challenging. But one of them we actually have under pretty good control. This is called the Lysosome Project, the LysoSense Project. It basically is, a lot of the problems with the body are associated with proteins building up. That the lysosome, which is the garbage collector of the body, it doesn't recognize them. They're ever so slightly changed. And so it doesn't gobble them up. They accumulate, damage happens. One example is macular degeneration, which happens to some ridiculous fraction of the human population once they get beyond a certain age, and someday I'll look up that stat. It may be curable through just gobbling up 1 particular kind of protein. And the Sense Lab has, before I got there, not my fault, come up with an enzyme that can gobble this stuff up. So maybe a proof of principle experiment is probably about a month, maybe 2 away from proving that you can engineer, you can use synthetic biology to make enzymes that gobble up 1 and only target, 1 specific protein that is causing us damage. We're working on another one for heart disease and Alzheimer's. That's another proof of principle experiment because it's a slightly different section. If that works, then we can prove the plaques that clog the arteries that cause Alzheimer's can also be affected in this very same way. So it's exciting stuff, and don't expect anything for about the next 6 weeks because we're moving. But we have a beautiful new lab, and we will have a lab warming party, and you'll all be invited. So, any questions?
You have 45 seconds left.
Oh my gosh. I can talk more. Give me some questions. Come on. I know this stuff. I want questions.
I have a question.
Yes.
What sorts of models do you use or will you use for your research and your testing?
At the moment, it's all tissue cultures. We're basically growing things in an incubator and watching what happens. We're making a little substrate for the enzymes to eat, and if it all goes well, we're golden. The step of that particular experiment is making sure that the particular enzyme gets into the lysosome, which is then going to gobble things up. We're not there yet, but we may have pictures soon. Yes.
I read something recently that Alzheimer's have been linked to HSV1, that the plaques have been genotyped as basically being HSV1.
I read that, but you suddenly stepped beyond my science threshold.
Sorry.
What's the funding source, and who will own these ideas, and do you know what they want to do with them?
It's a nonprofit. We are privately funded through donations, and we actually don't believe that a nonprofit can't actually be profitable. So we're going to find a way to make sure that we have control of the technology, patented perhaps, but then try to get it as broadly distributed as quickly as we can so that everyone can benefit.
So no umbrella corporation.
Well, we may spin off for-profit subsidiaries that can focus on a single idea, but there are difficulties. As a nonprofit, you really have to look into the legal situation and the distribution of labor and things like that to make sure that will work effectively for both. Yes.
Last question.
Have you considered just putting it in public domain?
Yes. And that argument isn't dead. That discussion isn't dead.
All right.
I have the sneaky suspicion that parts of it will totally be open source, but that parts of it that could help the foundation gain some profitability to expand the research to all 7 areas, you know, we still have to grow until we at least get that far.
Here, here.
Thank you, Tanya.